So I will just start my presentation now. Can you see the screen shared? Uh, I cannot hear anything. If everything is good, I will just go on with my presentation.
Just fine. Yeah, go ahead.
Okay, great. I can hear you now. Okay, so good afternoon, everyone. My name is Minzhi, and for today's learning talk, I've chosen a past work that is very related to today's social intelligence theme, specifically giving some insights on multimodal social intelligence related to audio. This work is about interactive evaluation of large audio models. With the insights about the need for more interactivity and consideration of non-text modalities, we explore the interactive evaluation of large audio models. Compared to text, speech allows faster and more efficient interactions. Because of this, speech interaction represents a natural step towards a more seamless and human-like interactive experience. Based on this idea, researchers have started developing large language models that can directly process audio inputs, often referred as large audio models. Recent efforts such as AirBench and AudioBench have focused on evaluating these models by combining a wide range of existing static benchmarks. Similar to how we assess text-based language models, the evaluations test large audio models in zero-shot and few-shot settings. However, while we've seen growing interest in evaluating large audio models nowadays, it's still unclear whether current benchmarks, especially static ones, truly reflect how users perceive model quality. The question is central to social intelligence AI because a model's effectiveness ultimately depends not only on task accuracy, but also on whether users find its response appropriate, natural, or aligned with their actual needs. Up to the time we worked on this paper, no study had collected user preference data specifically for large audio models. So this creates an important gap as we don't know how benchmark results align with actual user judgments. Therefore, researchers lack clear guidance on how to design models that better meet user needs. To address this gap, we collect a large-scale dataset of real user interactions. Each participant interacts with one of six speech-in, text-out systems, and this allows us to investigate three important research questions, namely, what are the tasks user expects large audio models to perform? What large audio models perform the best at those tasks and the reasons for that, as well as what are the static benchmarks that best estimate the user preference. To collect user feedback, we built a web-based interface on Gradio. When users arrive on the platform, they are asked to use the model just as they would for a voice-based AI assistant. After each interaction, users see two anonymous model responses to the same query. They then choose which response they prefer. This pairwise comparison gives us a clear sense of relative model quality. To understand why users make certain choices, we also let them explain their decisions, either by typing or speaking their thoughts. To understand how people use large audio models, we group user queries using k-means clustering algorithm and found four main types of interactions, namely task execution, knowledge expansion, chat, and advice seeking. To gain a deeper understanding, we also listened to 100 randomly selected audio recordings and classified them into each of the four categories. We found that about half of the users asked knowledge-related questions like, what is a galaxy? Around 17% were seeking advice about different aspects of life, and 16% engaged in casual chats like, how are you or what's your name? And 10% asked for task execution, such as drafting a summary or defining a term. These patterns give us useful insights into what users actually expect from speech-based models. For example, since knowledge-related questions are most common, it's important for audio systems to have accurate and up-to-date factual knowledge. possibly supported by retrieval. We then use the Bradley-Terry model to turn the pairwise preference data into overall model rankings. And surprisingly, we found that closed source models like GPT-4o Audio achieve the highest scores on static benchmarks, but they are not the most preferred one in real voice-to-text interactions we collected. Instead, the ASR pipeline built with Whisper v2 transcription and then Llama 3 text model turned out to be the most preferred system. A potential reason for this observation, we hypothesized, is that most of our users ask simple, everyday questions rather than ones requiring deep or subtle speech understanding. Because we place few restrictions on what users could actually ask, they naturally interact with the models in ways that didn't demand complex audio reasoning. This finding suggests that for general single-turn interactions in the speech-in, text-out manner, the most effective way to improve current large audio models is to distill some capability from text-based language models and enhance the interactive capabilities thereafter. To better understand the reasons behind these preferences, we manually analyze 100 user explanations. From this, we identify 5 main reasons. First, the level of detail in responses is the most common reason, mentioned by about 1/3 of users. People generally prefer models that give specific, concrete, and in-depth answers. Second, helpfulness matters a lot. About 1/4 of users mentioned that. They favor models that understand their questions and provide useful answers, and dislike those which refuse to respond or go very off topic. Third, language appropriateness influences about 12% of preferences. Some models reply in a different language from the user's inputs, which makes the responses harder to understand. Next, users care about accuracy in responses. They value responses that are factually and numerically correct. This also echoes with the previous finding that one commonly seen user query is knowledge expansion. Finally, human likeness appears in another 11% of explanations. Users tend to have different preferences. Some may prefer models that sound friendly and conversational, while others like the models more when it clearly distinguishes itself from a human. So this shows that the ideal degree of human likeness actually depends on individual preferences and remains as one dimension that could be personalized. After gaining a better insight on user data, another key question is how current benchmarks can reflect these preferences. Therefore, we conduct the static evaluation by taking a superset from speech-related tasks in AirBench and AudioBench. First, we check how well individual benchmark predicts user preferences and found no single dataset can do this well. While a single benchmark doesn't strongly predict user preferences, we wonder if aggregating benchmarks could work. To test this, we run a mixed effect logistic regression model with user preferences being the dependent variable and model performance difference on each independent dataset being the independent variables. And this regression model also shows a low R-square of 0.3. It means that current speech benchmarks have limited power in predicting what users actually prefer. However, some benchmarks do show some positive correlation, such as public SG speech, but this is actually one benchmark that could be solved using text capability. So in summary, when we look at what users expect from audio models in interactions, it's clear that users value efficiency. They mainly ask some tasks that could be solved by text models. Also, the models that perform the best for these tasks tend to be pipeline systems. This makes sense because most of the user preferences focus on quality and style of the text output. Moreover, the static benchmarks we currently collect don't reflect user preferences very well. They heavily focus on some audio analysis capabilities, but they do not necessarily predict what users actually need or require during actual interactions. So more broadly, these insights may also inform how we study social intelligence across other modalities beyond text, where modality-specific capabilities are not the only focus. In the meantime, prioritizing user-centered interaction quality is also important. So I hope this could be the main takeaway related to social intelligence. Now it comes to the end of the whole presentation. I hope you like the contents of this talk and feel free to reach out to me for further discussion. Thank you.
Question for Ella. Any question for Ella? Maybe I'll ask Ella a question. So Ella, Isong here. My question is, I'm wondering how this model handle dialect, like Singlish.
Oh, that's an interesting question. I think in our study, we only collect those like queries on prolific platform where the crowd workers are in the US based. And it would be an interesting extension to study like different user needs across geographical or cultural landscape.
Thanks, Ella. Okay, so
Thank you.
with that, we can wrap Ella's talk. Let's give Ella a few more hands.